equals to y equals to sine x, right?
Yeah.
So this is the max point, this is the minimum point, right?
Yeah.
Okay, good. So let's assume you don't know the basic curve of sine x. So y equals to sine x, you differentiate dy dx, you will get, these are special differentiation function, so you get cosine x. I remember I asked you to memorize this. Differentiate sine x, you get cosine x. You differentiate cosine x, you get negative sine x. You differentiate tangent, I think you get secant square x. And then you differentiate ex, you get ex. Ln x, you get 1 over x. So you have to memorize all this. Okay, so I differentiate this, I get this, right? Make sense?
Yeah.
Okay, good. Now, how do you decide? Okay, so this is the gradient function, right? Right?
Yeah.
This is a gradient function of sine x, right? So now, you know that this is 90 degree, and you know this is 270 degree, right?
Yeah.
Okay, and you know that the 90 degree and at 90 degree and 270, they are the turning points, right?
Yeah.
Oh, I don't have space to move. Okay, I'm so used to this app, and then now I move to this. I thought I can move. No, I can't move. Okay, good. Maybe next time when I read a book, maybe I will try to zoom in and out also. Okay, never mind. So you know that at 90 degree is the max point. At this 270 is the minimum point.
Oh, so the gradient function.
But the thing is, how you justify this? Let's assume you don't know the curve. How do you justify? Okay, is
justify
to
that
justify.
90 degrees
So
is maximum.
yes,
Oh.
how do you justify? Is you do one more time differentiation, which is 2 d2y dx2. This one you will get back cosine, you get negative sine x.
Wow.
So this is called the first derivative.
Oh, so I've been learning first.
Yeah, so second derivative. So the meaning of first derivative means derive.
Yeah.
You derive. So derivative means you differentiate once. Second derivative means you differentiate twice. So this is your derivative. This is your second derivative. Okay?
Okay.
Okay? The first derivative is the gradient function. The second derivative is the differentiation of the gradient function. Okay? But we don't have a name for this. Okay? So now, how do you know whether the 90 degree is maximum, or how do you know 270 is the minimum? Is make use of the second derivative. If the second derivative turn out to be negative means what?
Yeah.
Frown.
Oh, maximum.
Then if it's positive, is happy. So that means just sub in the value. Sub in. Let's say you sub in 90 degree to this. What do you get? What do you get? Right? Negative sine. Yeah.
A negative value. Yeah, -1.
-1. So it's -1, right? So -1 is negative, right?
Oh.
So therefore it's a max.
For 270 is positive.
So for this, is it positive?
Yeah.
Really?
Positive.
Oh, okay, so it's +1. So it's a minimum.
Really? I mean,
okay.
Isn't it supposed to be
Yeah.
positive?
Which one?
Like a sign, negative sign 270.
I don't know. I need to use the calculator.
But
never mind. So yes, so that's how you justify. Okay? If you don't know this. Understand? So similarly, if we make use of the question just now, can you give me the question just now? I just want to the gradient function.
Oh, you mean okay.
The first derivative. Okay. To simplify stuff, I just use y prime. Is.
Let me send this picture.
No need. I just want to read out quickly. So this is 3x2, 8x plus 6.
No, I don't know.
For what? You can charge it here, but it's too far away. Okay, never mind. You can take a rest. 15 minutes rest. Good. Okay, good. So this is the first derivative, right? So the second derivative will tell you that point is a max or minimum, right?
Yeah.
Yeah.
Okay. Yeah.
Right.
Yeah.
Right. Okay. So never mind. Let's sketch this out. So the y function is x3. Tell me x3.
X3. Oh, x about 3.
Yeah.
Minus 4x squared
4x squared
plus 6x minus
plus
3.
6x what?
Minus 3.
Minus 3. So this is the function. This is the gradient function. So let's do it one more time because it's going to help us later.
Oh, so it's
later on.
Double.
Yep. So second derivative. Double apostrophe. So now I want to sketch this out. Because only when I sketch the function out, then you get to see the maximum point, minimum point. And then we want to use the second derivative to verify. Just now I show you the sketch, I prove to you mathematically, right? So same thing, I want to do it. So I'm going to sketch this out.
That time, like last class, we had a debate whether
Debate?
you to prove if this one has a maximum or minimum point.
No, there was no debate. I asked you how. And somehow you try to figure out.
Oh,
Then
yeah,
I
yeah.
said close, but not entirely right.
So this was the thing
Yes,
you're trying to say.
yes. Y equal x to power 3
Yeah.
It's only 15 minutes.
minus 4x.
Oh wow,
What? Wow.
time flew by. I
Yes.
don't know. Okay, then you just wait.
Yeah.
Listen to this.
Minus 3. Yeah. Okay, good. So this is the one.
Oh yeah, while doing this question, I used the GeoGebra to see.
Nice. So this is the one.
Yeah.
Oh. That is quite funny already. Never mind, it's good to have this exercise. I will tell you why it's good to have this exercise.
Why is it quite funny?
Later you will see. No, I don't want this. I want to crop this out. Then if you manage to sketch this out, then how can you get the P here and the Q there?
Oh, I just saw how the graph looked.
Doesn't make sense. If you have used the GeoGebra, you wouldn't have that ugly and the wrong points. Doesn't make sense. Okay, good. So this is the sketch, right? And then if you see for this graph, right, is there a maximum point? Doesn't look like there is a maximum point. Because maximum point and turning point,
It's
they are
5:45.
what?
Like,
They are flat.
yeah.
Do you have a point that is flat?
No.
Doesn't look like there is. Okay? But we can see whether
Maybe if you
whether there is a
Maybe if
flat
you
point.
like,
I should equate the gradient function to 0. Because when the gradient is 0, that means flat.
yeah, you told me when I asked you a question,
yeah.
the stationary point.
Yeah.
You said the gradient equals 0.
Yeah, so that's why I equate this to 0. I want to see whether I can equate this to 0 or not. So can you help me figure out this? Use a calculator. Is there a point? Maybe there is.
No.
Why? Imaginary. Next one.
Yeah, both ways.
Okay, good. So there is no imaginary point.
Oh, you mean no?
Oh, yeah, no, sorry. So there is no stationary point.
You had what? Two
Because
before this?
because there
Because there are no x value.
because
n-
because
on-
because there's no stationary point because when I equate it to 0, which is this, so
Yeah.
there is no
x value or root.
there is no there is no stationary point because gradient function equal to 0 returns no value, returns no real value. Right? Because it's like you want to have a stationary point, but they don't give you a value.
Okay.
So there is no point to continue for the second derivative because there is no stationary point, then there's no point to talk about maximum and minimum already. Does it make sense? Does it make sense?
Okay.
Okay, good. Can I have a previous question?
Like previous, like 13, like
Okay,
12.
never mind. I can create one. Let me see. Oh, this one is even worse. This one. Sorry, this one is good. Not that good, but good enough. Good. This one is good, but a bit ridiculous. Okay, let me just zoom out. Wow, this is super ridiculous. Let me see.
Wow.
Okay, good. This is quite ridiculous, but looks okay. Let me see. Never mind. Okay, good. So, I hope you see there are two turning points.
Yeah.
So let's do this together. Get this out. So, this point and this point. Okay, good. So, in this equation, this function. No, this is not what I want. So just grab it to this. Okay, so let's do the first derivative, which is 3x2, 26x plus 10, right?
Yeah.
So you equate this to 0, then you will see whether you have stationary point, which is turning point, right? So stationary point means
Gradient
means
equals 0.
turning point. Yep. Gradient function equals to 0. That's the meaning of it.
Yeah.
Okay, so I equate to 0. See whether it returns me any value. If it returns me some real values, then that means there is. Okay? So you equate this. Can you help me out with this? Punch in. It might not be exact, but it should be real. The one with I means imaginary value.
Yeah.
So x equal to?
8.26.
Yep, good.
And then next, 0.40.
0.40. Okay, good. So you have two real values. Okay, so therefore you know that. So I think this is pretty accurate because you see here 0.4. Can you see?
Yeah.
.2. Okay, pretty accurate. So now we want to ask ourselves whether this is max or min now.
Oh, then you use second derivative.
Correct. Based on the sketch just now, this is the max. This is the min. Let's see if the second derivative can help us determine or not.
The 0.40 is max.
Max.
Okay.
Right, is min. Right. So let's do one more time. Second derivative. Oh, I can't move. Yes. Okay.
You're like,
Yeah, I keep moving.
move.
Yes.
Maybe you
So
should
it's-
use.
Never mind. It's okay. Okay. So focus. So this is the second derivative.
Yeah.
So now I'm going to sub in the x1 into it. So what's the value?
6,
So
8,
6 times 8.26 minus 26. 20? 20? 3.56.
3.56.
So this is positive, right? So positive is happy, right? So minimum point. So the x1 equals to this is the minimum point. Yeah, good.
The 0.4 is.
Yep, so 0.4 is 6 times 0.4 minus 26. I can tell it's a negative already.
3.6.
Okay, good. So this is negative. Negative is front face. So this is a max. So this is the way to test whether they are what nature. The nature of the point.
Wait, that was one of the questions.
Yeah, exactly,
but you
exactly.
never taught me.
Exactly. So this is the nature of it.
Oh, this is. Oh yeah, I forgot to ask you the nature
Yeah,
question.
no problem. So this is the nature. So the nature is either maximal or minimal. Okay? Yep. So that's how you use the second derivative to get the nature of the stationary points. Okay? Good?
Okay.
Okay. So yeah, we still have time, then we talk about this question. I think I'm still familiar. I'm familiar with this.
Maybe you just put it.
Yeah, I should just use this. Okay, I'm not going to do the 13 because 13 is just simple differentiation of special function. So I'm going to do 13. I'm going to do 14. So for given that, show that when x is positive, y increases as x increases. So how do you show this? Okay, you know what's the meaning of y increases and then x increases?
So when y is proportion directly proportional or something. Well, y increase then x will increase also.
Yeah. So how do you show?
So it's like kind of like going up. Like,
So y equals to 2x4 minus 4 x2. How do you differentiate this one? So three types, term by term,
product.
chain rule, and product, right?
Yeah.
This one doesn't look like product to me
Yeah.
because you divide.
Actually, you can make it into product.
Exactly.
But
And this is usually a trap. So how do you do this is this. You split partial fraction.
Huh?
Then it's a term by term. So you can change this to 4x to the power minus 2.
I see.
Okay, so now you can differentiate already.
4x.
Yep.
4x minus.
Plus. Done.
Plus.
Because your minus 2 you bring down
Yeah.
to the front, so the times is 8. So this one minus 1 is minus 3. So this is the gradient function. Okay? Okay?
Yeah.
So how do you show y increases as x increases?
Y increases x. Oh, show that there's no stationary point. Is it? Because if there's no stationary point, that means
It goes to 0.
y.
Is equal to 0. Then you times x3, right? So it's 4x4 plus 8 equals to 0. So 4x4 is equal to 8. Okay, there is a stationary point. Plus, minus, square root. There's a stationary point.
What does it mean by when y increase, x increase?
Yeah, so what's the meaning of that? Oh, when x is positive. X is positive.
Is this literature?
So when x is positive, okay, we talk about positive value. Yeah. What's the meaning of that? When y increases, x increases. This is proportionality.
That's what I just said.
Sec 2.
I said.
What's that formula?
Direct.
Y equals to kx. Do you have y equal to kx?
Yeah.
I think so. Right? So, or if you don't look at this, it's okay. But at least you have the 8 equal to 4x to the power 4, right? So basically, this big X is your x to the power 4. Your k is equal to 4. And then your y equals to 8. So this is...
I thought I told that.
Yeah. So basically, you just tell 8 equal to 4x to the power 4. It matches the y equals to kx.
Okay.
Okay? And y equals to kx is direct proportional.
Yeah.
I need a witness. Oh, never mind. This is recorded. I can rewind this and see if someone say it's direct proportional. I didn't hear that from you. Before I write this down.
I know. You want yes.
Yeah, never mind. So I can
Nah, you
listen
must- you
later.
must.
Yeah, sure. It's recorded anyway. Okay,
must
so
see it.
that's how you get the that's how you get the this part 2 marks.
Okay.
Right? Basically, it matches the proportionality y equal to
Formula.
kx formula. Okay. Then it says determine the range of value for which is a decreasing order. You know what's the meaning of decreasing order?
Wait,
Decreasing function. I'm sorry.
Function is a decreasing function.
Yeah.
What?
Decreasing function means it goes down lah.
Yeah, but how
That's the meaning. Okay.
how do you-
Decreasing function means it goes down.
That means gradient is
Negative. Yes. Okay. So decreasing function means it goes down. So it means the gradient is negative. So what you need to do, you need to show that when your this gradient function is less than 0. Oh,
Okay.
negative. Sorry, it's negative, not negative 1. It can be negative other. Does it make sense?
Yeah.
So you just need to show. So decreasing function means like this. So m equals to gradient is negative. So it means need to show the y prime. I mean, y apostrophe y first derivative is negative. So means y third is smaller than 0. Does it make sense?
So when you do
So therefore you differentiate this first. How do you differentiate this then?
x over x squared. plus-
No, you cannot use partial function. This one is product rule. Because when
Oh.
you partial function it, it doesn't help.
Yeah, because the phi is there.
Okay? So you
Why?
don't always do the
So x plus 2 times
okay, so
1
it's
over x.
x plus 2 times x squared plus 5 square root, I mean to the power minus 1. So this is your u, this is your v.
V.
So your u
Then
prime
u
is
prime
x,
times
1
v.
is 1.
Isn't it u prime times v?
U prime is 1.
Yeah.
Yeah, here ma.
Yeah.
Then your this v prime is bring down the power,
Negative.
power minus 1, and then you still need to do inside, peel the layer.
Mm.
This is the first layer you need to peel, and this is the second layer you need to peel. You get
Onion.
times 2x. Yeah. So therefore you get this minus 2x, x squared plus 5.
What happened?
I don't know. Sometimes technology just fail us. It's common. Okay, good. It's back. Sometimes maybe because of this app, it's online and then never mind, I'm going to use. So after that, can you help me out this times this? Can you continue from here?
Yeah.
Yeah, please. Help me do some of the heavy lifting, yeah? Help me out, no, help me out.
It's 6
okay.
o'clock.
So that's x. Okay, that's
So this is x squared
x.
plus 5, then to the minus 2, right? Then you just cross multiply. That will be your y derivative.
Wait a minute.
No, you do it on a piece of paper.
You mean this piece of paper or?
You can, if you want to use, you can use this also. You can do it on your iPad, then later you just send over. Just blank page. Is it back? If it's back, I can do it. Okay, no, it's not back.
Right. Okay. U prime times v, right? So is
It's x plus 2 bracket times this thing.
yeah. So for the first equation.